Let's set up the same AI model to run locally on 3 different devices. One costs $80, one costs $250, and one costs $1,000. There's a lot of models that you can run locally on your own hardware to run AI chat applications like ChatGPT or Claude. By running it locally, there's no cloud, no subscriptions, no sending your data to companies like OpenAI, Google, or Anthropic. But some of these open source models are getting big and need some serious hardware. Today, we're running one that doesn't. For this test, I'm using DeepSeek R1, specifically the 1.5 billion parameter version. The world lost their minds when DeepSeek initially launched R1 a year ago, because it was a Chinese lab releasing an open weight model that was at least as good as OpenAI's proprietary O1 and O1 Mini. While it's been a year, R1 is still an interesting model for running locally. First, it's small. At 1.5 billion parameters, it's 5 times smaller than those 7B models that are pushing the limits of consumer hardware. That means lower RAM requirements, faster inference, and it can even run on something like a Pi. But small doesn't mean useless. DeepSeek specifically trained this model for reasoning tasks, which means it's surprisingly good at math, coding tasks, and logic puzzles. So you can write shopping lists, help with homework, generate code snippets, and answer questions while you're working, all locally and privately. And it's released under the MIT license, truly open source. No restrictions, no commercial limitations. You can do whatever you want with it. So that's the model R1. Now let's talk about the hardware that's going to run it. First up, the Raspberry Pi 5 with 8 gigs of RAM. This is $80. It's a single board computer, good for hobby projects and home servers. But can it run AI? Next, the NVIDIA Jetson Orin Nano, also with 8 gigs of RAM. This is $250 and built for running AI at the edge and robotics with a dedicated GPU, neural processing cores, and way more efficient power consumption than a desktop GPU. And finally, a MacBook Air with the M3 chip and 16 gigs of unified memory. About $1,000, it's what a lot of developers might use as their daily driver. 3 completely different machines, same AI model, same prompts. Let's see what happens. Okay, let's talk setup. I'm using Ollama. It's a free and open source framework that makes setting up local AI super easy. Let's set it up on the MacBook. First, let's install Ollama, and then download the model and run it. I included the verbose tag so that we'll be able to see our performance metrics. And that's it. Setting this up takes less than a minute. On the Raspberry Pi and Jetson, they're both Linux machines, but the setup is nearly identical. You're going to SSH into the device and then install Ollama, and then it's Ollama run to download and start the model. All right, let's try it out. I'm going to run 3 prompts on each device so that we can compare the answers and performance. One is a math problem, one is writing code, and then a logic puzzle. These are all the kinds of tasks that R1 is supposedly really great at. All right, first up we have our math prompt running on the MacBook. If a train travels 120 miles in 2 hours, then slows to 40 miles per hour for the next hour, what's the total distance? Show your work. Okay, it's running on our MacBook. It's pretty fast. You can see the thinking process happening almost instantly. And the raw output here is in Markdown, but we can see our answer. It's 160 miles. So that took 8 seconds with an eval rate of 72 tokens per second. It felt pretty smooth, actually really fast. So now let's SSH over to the Jetson and run it there. All right, same thinking and reasoning process. And we get the same answer, 160 miles. That one took 20 seconds at 22 tokens per second. A little bit slower, but it's kind of like the difference between a fast typer and a slow typer, but you can still read it in real time. It's still very, very usable. And we got the same answer. And finally, let's SSH into our small but mighty Pi. Okay, this is very slow, but it's working. So the Pi is thinking through the problem step by step. Oh, and it's kind of hard to see in this Markdown, but if you had an eagle eye, you might have caught that the model messed up on one of the variables. So let's remember that LLMs are probabilistic, choosing the most likely answers. They're not deterministic like a calculator. So that means that every time you run a prompt, there's a chance that you'll get slightly different reasoning and sometimes even different answers. Like here, The final answer here shows 280 miles. So the model made a mistake, but it was an error in interpretation, not in calculation. So we can talk about that more in a little bit. But that took 48 seconds at 9 tokens per second. Okay, so the model is identical running on all 3 devices. It's got the same weights, same reasoning, same intelligence. The only difference is how fast each device can crunch through that math. Okay, let's quickly go to the other prompts. Starting with code generation, write a Python function to check if a number is prime. Okay, the MacBook is flying through it. Jetson, totally usable. Pi, you're gonna wait, but it works. Code quality seems identical. Again, they're all running the same model, so the reasoning is the same. It's the speed that's different. And finally, let's see our logic puzzle. I have 3 apples and buy twice as many oranges. If I give away half my fruit, how many pieces do I have left? Theoretically, this is where R1's thinking capabilities should really shine. And I see there's some ambiguity with this prompt here that the model's gonna need to work through. So it's literally thinking through the problem. I have 3 apples, twice as many oranges, means 6 oranges. Total is 9, half of 9 is 4.5. Well, wait a moment, you can't have half a fruit, so let me think about it again. And that's what makes DeepSeek special. It's not just spitting out some answer, it's actually thinking and making decisions in stages. Okay, again, we see the difference in speed, but the model gets to the same answer on all 3 devices. Back to how LLMs are probabilistic and how they can be wrong, I did run these prompts a couple times just to see how reliable and consistent they were. And while it can be wrong, it doesn't matter which device you're running the prompts on. If accuracy is important for your particular use case, make sure your prompts are crystal clear and that there's no ambiguity. The model should have all the context that it needs to answer the question. And for really critical tasks, you might want to run the prompt twice and then compare the answers before running any kind of automation or even returning a response. All right, let's take a look at our benchmarks. The MacBook is super fast, Jetson is still usable, and the Pi is slow. But speed isn't everything. The MacBook is 9 times faster than the Pi, but the Pi is 12.5 times cheaper. And the Jetson sits right in the middle, about 1/3 of the speed of the MacBook at 1/4 of the price. So what device should you use if you want to run an AI chatbot on your own hardware? If you're learning AI or you're on a budget, or you're just okay waiting for responses, it's incredible that an $80 computer can do this at all. A few years ago, this would have felt impossible. It's slow, but it works, and for learning and experimenting, it's good enough. If you're building AI projects and need something responsive but don't want to tie up your main computer, the Jetson is purpose-built for this. It's got a GPU, it's got CUDA and Tensor cores optimized for AI workloads. And if you already have an M-series Mac or gaming PC with a decent NVIDIA GPU, and you don't need any dedicated hardware, the setup is identical, the performance is great, you're all set. The beautiful thing? You learn it once and you can run the exact same workflow on any workstation. That's the power of Ollama and open source models. We ran DeepSeek R1, the 1.5B distilled model. By default, it's compressed to 4-bit. Less memory, faster inference. Good for small edge devices like the Pi. DeepSeek R1 is small and genuinely useful, but if you're interested in other models, it's not the only one out there. You've got 2 dials to play with, brain size and compression level. Brain size is the model, 1.5B, 7B, 8B. Compression is how tightly you pack it, like Q4 or Q8. So you can either turn up the brain size, step up to models like Mistral 7B or Llama 3 8B. You'll get better reasoning at slower speeds. And if you've got more RAM, you can turn up the precision, from Q4 to Q8. Same model, same training, more detail, more stable, slightly heavier. And again, the beauty of Ollama in these open source models is that you can try any of these models with the same straightforward commands that we did today. So that's it. Same AI model running on 3 completely different devices and wildly different performance. If you've got a computer made in the last few years, you can try this out for yourself. Besides language models, if you're interested in vision models, I have another video where I'm running through object detection on the Pi 5 with an accelerator, and the Jetson. Thanks for watching. I'll see you in the next one.